Hey everyone, so today we're starting a new topic called integration. And there are quite a few different uses for integration, but effectively it's linked to differentiation because it is the reverse of it. Okay, so if you think about it, to differentiate something, we times by the power decrease the power by 1. Decrease the power by 1. So if I want to reverse this, increase the power by 1, divide by the new power. That is how we integrate. Okay, increase the power by 1, divide by the new power. If you want to write that down somewhere, you're going to be using it all the time. Increase the power by 1 and divide by the new power. Okay, and that is the opposite of differentiating. Now, there are more uses for it than just the opposite of differentiation, but that's the first thing that we're going to start looking at. Okay, so today's lesson is going to be, and well, both lessons basically with me this week are going to be practicing this. Okay, just like when we first started off differentiating and we spent ages, you were all just chanting at me, weren't you? Times by the power decrease the power by 1, times by the power decrease the power by 1, and we spent a couple of lessons where you were just really confident doing that process. That is what this week is going to be with me. Okay, so let's have a little look at a couple of things over here. Okay, so that's basically what it's just been talking about. The only thing really that I want to talk to that's on there is this, that plus c. We call that the constant of integration. Now the reason that we have to put that there, whenever we integrate something, we have to put a plus c at the end. The reason for that is because if, let's take the quadratic x squared plus 5x minus 6. Now if I differentiate that to get dy by dx equals 2x plus 5, that minus 6 effectively disappears there, doesn't it? Which means that when I integrate this, integrating 2x will give me x squared. Integrating 5 will give me 5x. But I don't know what number there was there effectively. So what we have to think about is that whenever we integrate something, there might have been a constant there that disappeared to give us the function. And that's why we put a plus c at the end of anything. Okay, so if I integrate this, I'll get x squared plus 5x, but I won't get the minus 6. And that c is there to represent there might have been a constant at the end that disappeared when this thing was differentiated. And sometimes we need to find that out. If we're figuring out a reversal of the equation of a curve, then obviously we need to know what that thing is there. But a lot of the time we don't need to know it, so we just put plus c in there to represent there might have been a number there that has disappeared when we differentiate. So all you need to remember about this really is just to put plus c at the end of all your answers for today. Okay, so let's have a little look then at example 1. So these kind of come in pairs. So what I'm going to do is I'm going to go through A. I'm going to then ask you to have a quick go at B, and then we'll go through it. So let's take this one. Find y for the following. So basically what it means is integrate this. So we've got the differential there, dy by dx, and I want y. So let's increase the power by 1. So that will go to x to the 5. Divide by the new power. Well, effectively add a coefficient to 1. So that's going to give me 5th x to the 5. And then I just put plus c on the end like that. Okay, right, pause the video, see if you can do that one on your own. Okay, so what should have happened here was you got y equals, increase the power by 1. Remember that if we start off at minus 5, notice I'm using my calculator for this, minus 5, if I add 1 to that, increase it, where do I get to? I get to minus 4. So our power is going to increase to minus 4. Dividing by the new power means that will then turn into minus a quarter, x to the minus 4, and then plus c. Okay, increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power. That's all you're doing there. Okay, over the page. Right, notice that the notation is changing this time. It's now saying figure out f of x if I give you f dash of x, exactly the same as what we did on the previous one. Okay, the only little difference here being, you see that half properly? Okay, so increase the power by 1. means that will go to, I'm at half, aren't I? Increase that by 1. Gets me to 3/2 again. Just do it on the calculator if you are at all unsure. And then I want to divide by the new power. So I want to do 3 divided by 3/2. Again, just do that on your calculator if you need to. 3 divided by 3/2 gives us 2. Okay. Right, and I'll talk you through this one. Plus C there. So for f of x here, effectively there, remember what happens when the x disappears? It goes to x to the power 0. So effectively there, we have a 3x to the 0. Any constant, any number has a 3x to the 0 on it. Increase the power by 1, so we get x to the 1. Divide by the new power, it means the 3 will just stay the same. So we just get 3x like that. Right? Right, for these ones, I'm going to give you a quick your turn here. So can you have a go at these two, please? So f dash of x equals 5x to the power of a third. And what about if you've got f dash of x equals 6? Okay, so pause the video, have a go at those two, please. So what you should have got here, if you increase a third by 1, you will get 4/3. So that will go to x to the power of 4/3. And then again, on your calculator, 5 divided by that new power, 4/3. Give me 15/4. So I'm going to get 15/4x to the power of 4/3. And don't forget to put your plus c there as well. Okay, so with this one, what you should have been doing there, f dash of x is 6. So when you integrate 6, well, think about this one, we integrated 3. We ended up with 3x, didn't we? So when I integrate 6, I'm going to end up with 6x plus c. Okay, so basically if you get a number or a constant, if you integrate it, you just put an x on the end of it. Okay, so 5 integrates to 5x, minus 2 integrates to minus 2x. P, if P is a constant, integrates to px. Right, let's have a look at this one. Example 3. So when dy by dx equals 6x plus 2x to the minus 3 minus 3x to the half, find y. So what we do here is increase the power by 1, divide by the new power for each term. So the x there will go from x to the 1 to x to the 2. And then divide by the new power. I'm going to just write these like this for the time being. This one, increase the power by 1. Well, minus 3 will go up to minus 2. Divide by the new power, so that's 2 over minus 2. Increase the power by 1, that will go to 3/2. Divide by the new power, so we're getting 3 divided by 3/2, and then just simplify all that. When you come to do these things, eventually you'll just be able to do it. You won't need to look at this. You'll see, well, that goes up to x to the 2, 6 divided by 2, and you'll be able to kind of simplify it straight away. So to get from 6x to 3x squared, you just simplify that immediately. I'm just kind of showing you that line and working out there. You don't need to write that down if you don't want to, but there are little things that really have a big effect, stuff like this, so just be careful. Okay, this one, 2 divided by minus 2 means that they cancel out to 1 effectively, only on minus 1, which means that second term turns negative to minus x to the minus 2. And in this one, again, remember, just do this on your calculator if you need to. 3 divided by 3/2 gives me 2. And because it's got a minus in front of it, that's minus 2x to the 3/2 and plus c on the end there. Okay? So, what I'd like you to do, please, can you have a go at those highlighted questions there? I have put it in the little instruction things for the task. That one, that one, that one, those three, and that one at the end there, please. And then upload your upload pictures of your solutions, please, to either Teams or to Classrooms. Nice one.